Good morning, class. We are looking at college algebra, module 5, chapter 9, sequences and series. This is a practice test, which is part of the final exam, sequences and series. First, I want to remind you about the pledge. Before starting the exam, please read the following pledge. I pledge on my honor, and I will neither give nor receive unauthorized assistance, so on and so forth. Can't emphasize this enough. I want to make sure you realize you're taking the exam as though you're taking it on campus. In some of the cases, some of the examples, some of the questions, you may be able to use a graphing calculator, okay? So let's write the first 5 terms of the sequence. A sub n equals 9 times 1/4 to the power of k minus 1. So a quick reminder, what is a sequence? A sequence is a list of numbers written in a specific order. A sub 1, A sub 2, all the way to A sub n. That's the first, the second, and the nth term of the sequence. Accordingly, A sub n is the general term, and n being the set of positive integers 1, 2, 3 to infinity. A series is the sum of the terms of a sequence. So we want the first 5 terms, so replace the n with 1, 2, 3, 4, 5. So let's replace it with 1. This becomes 0, this becomes 1, and the answer is 9. Now, we are going to replace, by the way, the number here, okay? So, A sub 2. This is 1. 1/4 to the power of 1 is 1/4 times 9 is 9/4. And you can continue. Then if I change this to, 3, 3 minus 1 is 2, 1/4 to the power of 2 is 1/16 times 9 is 9/16. And we can figure out the rest of it. For the sequence, A sub n equals 2, A sub n minus 1 plus A sub n minus 2, and A sub 1 being number 6, A sub 2 being number 3, we want to find the first, second, third. We want to find the first few terms, everybody. So what are we dealing with? A difference equation, a recursive sequence, is an equation of the form A sub n plus 1 is equals f of A sub n, where A sub 1 is given, and f is a real valued function. A solution is a sequence A sub 1, A sub 2, A sub n, satisfying the given difference equation. So for example, right here, this is called the difference equation. It's a recursive sequence. A sub 1 is known, A sub 2 is known. So we have the first two. So the next one is to find A sub 3. And to find A sub 3, we have to go with the formula. Now, according to this, A sub n is 2, A sub n minus 1 plus A sub n minus 2. This is before that. So A sub 3 is 2, A sub 2. And A sub n minus 2 becomes A sub 1. Here's one easy way to figure it out. You let this one be 3. Okay, so 3 minus 1. 3 minus 2. That's how you get this. And so 2 times A sub 2, 2 times 3, plus A sub 1, 6. They add up to 12. So very straightforward, everybody. Now, what about a sub 4? If I want this one to be 4, let's replace this with 4. So this is 4. This is n minus 1. 4 minus 1, 3. 4 minus 2, 2. That's how you arrive at this. Which makes it a sub 4 equals 2 times a sub 3, which is 12, plus a sub 2, which is 3. And we get 24 plus 3 is 27. Now, as long as you can find a few, I'm going to leave it for you to figure out a sub 5, a sub 6 if need be, so you can easily come up with the rest of them. So I'm going to leave it for you to make sure you can come up with this as the final answer. Is very straightforward, not much to it. Determine whether the sequence is arithmetic, geometric, or neither. If the sequence is geometric, find the common ratio. So what do we mean by those? Arithmetic sequence happens recursively in the following format. A sub n plus 1 is a sub n plus d. That means if it's an arithmetic sequence, if you want the next term, pick the previous one and add a constant. Explicitly becomes a sub n equals a sub 1 plus n minus 1 times d. That is the arithmetic sequence. Geometric sequence, recursively, a sub n plus 1 is r a sub n, meaning if you want a term, pick the previous one and multiply it by r, a common ratio. Explicitly, a sub n is a sub 1, r to the power of n minus 1. So, in short, you look at their difference and you look at their ratios. One of them is constant. If the difference is a constant, is arithmetic. If the ratio is a constant, is geometric, otherwise none of the above. So for example, we may recognize the ratio of these two and these two are the same. So let's write the ratio of these two. That means a sub 2 over a sub 1 is 0.25 over negative 0.125, and you get negative 2. But this is not enough. Let's look at the ratio of these two. Look at the ratio of these two. Clearly, negative 2 divided by 1 is negative 1. 1 divided by negative 0.5 is the same. And you go with the second one, a sub 3 over a sub 2. So that is the proof that this is a geometric sequence with r being negative 2, according to the definition of a geometric sequence. So that's pretty straightforward, everybody. What about this one? If you look at 8 over 6, 11 over 8, 15 over 11, you see that they are not equal. So you can write, for example, right here is 8 over 6, the same as 11 over 8. The answer is no. If you do the cross product, they're not the same. Just for the sake of argument, if you recall, cross product must be the same, right? This is 64, this is 66. And right away, that shows that it's not a geometric sequence. Look at the difference, 8 minus 6, 11 minus 8, and so forth. If you look at 8 minus 6, you get 2. But 11 minus 8, you get 3. And so it's not an arithmetic sequence either. So what is it? Neither. Okay. This one again, we can do the same thing. So for example, look at the ratio, look at the difference, 1/2 over negative 1/2. I hope you recognize this as a complex fraction becomes a 1 over negative 4 or negative 1/4. But you're not done. You have to check these two and perhaps even these two. If I divide negative 1 over 8 by 1/2, I get the same number. And that proves it's a geometric sequence with r being negative 1/4. Write the arithmetic sequence, 32, 24, 16, and so on, in standard form. That simply means find a sub n. And I want to remind you, arithmetic sequence is a sub n plus 1 equals a sub n plus d. And explicitly in this format, this is what we are looking for. A sub n is a sub 1 plus n minus 1 times d. So the very first thing we're going to write down is a sub 1 is 32. D 24 minus 32 is negative 8. And you're going to double check, meaning let's do this too also. 16 minus 24 is also negative 8, although they have told us it's an arithmetic sequence, but check. And so we go with this formula. We are going to replace a sub 1 with 32 and d with negative 8. And normally they leave it like that. You can always simplify it, but a sub n is a sub 1, 32, plus n minus 1 times d. If you were to simplify it, just for the sake of argument, it would become 32 minus 8n plus 8, or minus 8n plus 40. Okay, so it can become simplified in that fashion. Again, if need be. All right, we are going to move on. Fill in the blank. 139 is which term of the arithmetic sequence 1, 4, 7, 10, so forth. And by the way, they don't have to tell us it's an arithmetic sequence. We should be able to figure it out. Obviously, here's the definition of arithmetic sequence. You always need the first term, a sub 1 is 1, and d is 4 minus 1, which is 3, 7 minus 4 is 3, 10 minus 7 is 3. So you really should check. So what is a sub n? A sub 1 plus n minus 1 times d. Let's plug in a sub 1 is 1, d is 3. We get 1 plus 3n minus 3. And 1 and negative 3, they add up to negative 2. So a sub n is 3n minus 2. Set this equal to 139. Move the negative becomes positive 2. You get 149, 41. Divide by 3. And n becomes 47. So it's the 47th term. So it's pretty straightforward, everybody. We're going to move on to the next question. Answer the following questions. Find a formula for the general term A sub n of the sequence, assuming the pattern of the first few terms continues. 0 0.8, 4, 20, 100, and so forth. So you have to recognize it as a type, okay? So obviously the first term is 0 0.8. Now, if it's one of those that we know, it's either arithmetic or geometric. That means we are looking for either D or R. So the first one is 0.8, D or R. And notice if you divide 4 by 0.8, 20 by 4, 100 divided by 20, what happens? A sub 2 over A sub 1 is 4 over 0.8. That is 5. The same as 20 over 4, which is 5. The same as 100 over 24, which is 5. And that proves it's a geometric sequence with R being 5, and you don't have to look for D. Clearly, the difference is not a constant. And so we use A sub n equals A sub 1 or to the power of n minus 1. And we replace A sub 1 with 0.8 or with 5. So that's the general term, everybody. What about A sub 8? Well, replace the n with 8. So we get 0.85 to the power of 8 minus 1, which means 5 to the power of 7. And you put it into a calculator, it gives you 62,500. Find the ninth term of the geometric sequence whose initial term a sub 1 is 4 and the common ratio is 2. So basically put it into this formula. So a sub n equals a sub 1 or the power of n minus 1, where a sub 1 is 4, or is 2, and n is 9 according to this. Plug in, plug in, which means a sub 1 is 4, 2 to the power of 9 minus 1, or 8. So by the way, you get 2 to the power of 10. I hope you realize this is 2, just for the sake of argument. This is 2 squared, so this becomes 2 to the power of 10. Okay, so it's pretty straightforward. Evaluate summation of 3 to 7 k squared minus 1. And what it means is just start with the lower limit 3. So you get 3 squared minus 1. The next one, 4 squared minus 1, 5 squared minus 1, and all the way to 7, and add them up. So the meaning of this is this. Start with the lower limit, 3 squared minus 1, 4 squared, all the way to the last one. Now, of course, just do the math. This is 9 minus 1, 16 minus 1, 25 minus 1, 36 minus 1, 49 minus 1, add them up, and we get 130. Again, it's pretty straightforward. Just plug in and it will do the job. Write the arithmetic sum using sigma notation, 9 plus 4, negative 1, and so forth. And again, reminding you of what is arithmetic sequence. And so how do we write that? In this case, the idea is as follows, everybody. Write the summation of n going from 1 to n of a sub n. We want to find a sub n and n. So we need to know what is the general term we put here and what is n. So which term? Term number 5, 5. Term number 10, the 10th one, and so forth. That's the idea. So according to what we have, obviously here's the first term, 9, and their difference is 4 minus 9, negative 5. It's important to pay attention to the sign. And so we have a sub 1, we have the d, and let's plug it into this. A sub n is a sub 1, which is 9, plus n minus 1 times d, which is negative 5. So this is 5 minus 5n plus 5. So minus 5n, 5 and 9, they add up to 14. And so we have this general term. In other words, so we got this one. Now we look for n. So this part is found. So how far do we go? Well, the last number is negative 26. That would be the nth term of this sum. So a sub n equals negative 26 on the one hand, on the other hand, equals to this general solution. That equation will help us find the value of n. And so move the 14 becomes negative. So we have negative 40 divide n becomes 8. And so here we have a sub n and we have the n. So it's pretty straightforward, everyone. By the way, it's really not a bad idea to check. You can add the sum to see if it gives you the same sum if you add up those numbers. The other thing that is important to check, n is 1, you should get 9. N is 2, you should get 4. N is 3, you should get negative 1. So that's the best way to do this. We want to evaluate the summation of 1 to 14, 3 times 2 to the power of n minus 1, and again, reminding you of geometric sequence and an arithmetic sequence. And so to evaluate this, you are going to add the first term to the second, to the third, all the way to the 14th one. So let n be 1, then let n be 2, and so forth, okay? So first, let's write the meaning of it. If n is 1, this becomes 2 to the power of 0 is 1. So it becomes 3. If n is 2, 2 minus 1 is 1. 2 to the power of 1 is 3 times 2 is 6. If n is 3, 3 minus 1 is 2. 2 squared 4 times 3 is 12. So it means add up those numbers. So that's the meaning of it, everybody. And so what is the first term? 3 what is the ratio? You can see the ratio right here from the general term is 2, or 12 divided by 6, 6 divided by 3. It's really a good practice to make sure that this works out. And so if you want to come up with the sum, S sub n is a sub 1 times 1 minus r to the power of n over 1 minus r. We are going to use that. Plug in. A sub 1 is 3. That's why we write this. 3, 1 minus 2 to the power of n over 1 minus 2. I mean, the denominator is negative 1, which means just evaluate the numerator and negate that. That's the meaning of it. So that's the general idea. What is n? Since we want to go all the way to 14, replace the n with 14. So this is S sub n. What do we want? S sub 14. S sub 14. Replace this with 14 to come up with the proper answer. Again, as I mentioned, the denominator is just negative 1. So you have to raise 2 to the power of 14, subtract it from 1, which becomes negative, times 3, and then negated again becomes positive. At this point, you can use a calculator, 49,149. So we use the formula, obviously. And that's the final answer. All right. Find the partial sum, S sub 11. It's called partial sum because you stop at some point. If it's n, and it could be S sub infinity, that means goes to infinity. And of course, when the ratio is larger than 1, this will go to either infinity or negative infinity. For the arithmetic sequence with A sub 1 being 9, D being 3, in this case, we are talking about the arithmetic sequence. And we have both of them. We need arithmetic sequence. And so the sum, there are two ways to calculate the sum. S sub n is n over 2, A sub 1 plus A sub n, or n over 2, A sub 1 plus A sub n. If you use this formula, it simplifies to 2A sub n plus n minus 1 times d. So again, this one, A sub n, if it's replaced by this one, will result in this formula for you. So we are going to use this formula. And n, everybody, is 11. So replace this one with 11, this one with 11. A sub 1, replace it with 9. N, replace it with 11, minus 1. D, replace it with 3. So 29 times 9, 18. This is 10 times 3, 30. 48, obviously 24 times 11, 264 is the final answer.